Hi everyone, we can finally walk around on the map. This is a quite complex task and we have to split it in multiple videos because no one will look at a 4-hour video, so we split this task up into multiple smaller ones. First of all, today we will talk about how controlling sites on Unity works. So how does the new input system work and how do I set up Cinemachine to have some camera following around the player. Just to show you that it's currently working, I have two clients. I have one Unity basically in the editor and I've built it one time and have run it. And the client here is controlling the red player, and if the red player moves, then it moves on the purple client also, and this works both ways. There we see it. And what also works, I have here on map, I have other players. I see that the other player is the orange one and the top one is myself. So the top one is disabled because we don't want to see ourselves duplicated. And when I let this player run to the far left, you can see at the top right on X where he currently is. And if he's far enough outside, then his state gets removed. So this client no longer tracks him, and also the game object will get removed later. But when we go back, sorry, I didn't show it to you, but I went back inside, it got tracking again. When I go back to the left again, the player will get removed. The thing is why the game object isn't deleted yet, that's because of jitter. Because we get from the server remove this game object, but while the server removes the game object, we also get a new state from the player and the game object gets recreated. That's why you see at Unity that currently the game object will flicker. I don't know if you see it. And it gets deselected. The issue is quite simple. It's on server side, it's already fixed. The client doesn't get new information about the old state. It's just network jitter. So it can also happen that the client gets removed correctly on client side. The reason why I didn't implement that for now is, or why I didn't cleanly implement that, is quite simple. We have remote player management, we go through the code in detail, and we also need interpolation. You saw the player jiggling around and it wasn't very smooth moving from the remote players, and we have to do interpolation and we have to do some kind of jitter protection. This is actually some work to do. It and cleans up the ordering of packages so that the latest package by server time is also in consideration. So when there's from the server a remove this player message, then this player doesn't get re-added again. We could also fix that because we have the server time when the events occur, but since we have to fix it anyway with interpolation and jitter, I didn't do that for now. But we will talk about this topic in depth in the next video, where we will talk about how this whole server, client and map partitioning works, because our map is actually partitioned in multiple spaces and there are some pitfalls that you have to consider, but we will talk about that in the next video. I know that I wanted to make a video about infrastructure as code. We will put that behind because it's already working, but I think it's cooler to be able to work around on the map, and I wasn't sure if I finished this feature in time so that I can show you something. Since I finished it in time, we talk about that. And like I said at the beginning of the video, we will talk about how we set up the camera and how we set up the controls for the user. So let's start with the user controls. We use the new input system, so I created a folder called input, and here you can right click and create a new input actions. When you create input actions, you give it a name and then you get this object. For how I use the input system, we need to tick this box, generate C# class, and then it will generate the C# code for the new input system. You don't have to manipulate it by hand, everything will be great. We can give it a namespace and everything, but we don't need that for now. Then you press edit asset. And what I did here, or how the whole input system works, you can define action maps. And with action maps, you can enable and disable them. So you could have, for example, if we implement mount, maybe mounts are controlled differently, you can't cast skills on them, then we could make an action map for mounts, and we could also make an action map for walking around. We could make an action map for fighting and everything. And this way we could disable and enable action maps depending on what we need. Currently we can just run around on the map, so I press plus and edit an action. Let me do some for the video, and we will remove that one because I don't use it. Let's call it video, and then we have a new action. And as action type we want to have pass through, and then we want to have vector 2, which is basically horizontal and vertical axis in our case, what we need, because we want to maybe move around with the gamepad or with the keyboard. And let's call that move around. And with that action we can add bindings, and we can add a 2-vector composite binding because we made it 2-vector 2 control type. And what this does is it adds something like for up, down, left and right. So for example, we can rename that with F2. We could say keyboard WSD, and then we can say up is, and we press W, then you see keyboard W, down is S, and keyboard S, left is A, keyboard A, and right is D, keyboard D. So this is the binding for keyboard WSAD. You can also rebind them. The code for this is not that simple, but it's possible. So you can make a screen where the user could change their controller inputs. Let's say they want to use the arrow keys instead of WASD. That's possible. You can rebind them, but we don't do that for now. And I want to add another binding, so both will be binded to move around. And I want to have gamepad left stick. So with that configured, it will work that we can move around with the left stick and with the keyboard. Let me remove that again. And that's actually what I implemented here. What I also recommend is that you have a stick dead zone configured when you use this input stick. This means when the player is moving just a little bit, or maybe the analog stick isn't configured perfectly fine, then it doesn't move around your character directly, so you have some kind of dead zones in which nothing happens. It's best practice to do that, and you can tweak those values, but I leave them for now. And when you save the asset, the code generation that we configured runs, and this code is actually generated. You don't need to look at this code, and I never did, to be honest. I wrote a player controller, which is this code. Let me zoom in a little bit. And we have this player controls because I named it player controls. The class is also named player controls. And we have this player controls, and we get it. And then we have our controls movement, which is, if you remember, my action map. And what is interesting, the action map is enabled by default, but the controls aren't enabled by default. So for the controls, we have here via our pub subsystem the availability to enable and disable the controls, because we just want to enable the controls after loading screen and everything is done. Then the controls get enabled, but you just get a new instance of the controls and you just call enable, and the controls actually work. And then we get our action map, and in the action map we have the action run. And so we get the action map and we get run inside the action map, and there's performed. And performed is an event, so multiple people can register to that, but we just need it one time for now. And this get a context, and this is a context from the new input system, which allows you to read the values. And since we have a vector2, we want to read the value vector2, and I save it in a local variable for later use. So every time the control changed, someone changed a left stick on a gamepad or on a keyboard, then it will actually set this vector, and I use this vector to move the player around. There are multiple ways to move player around in 2D space. One is directly manipulating the velocity. That's what we do here. This gives a very snappy feel. So when I stop pressing something, the velocity of the x-coordinate is directly set to 0, so it feels very responsive. Another thing we could do is we could manipulate the position directly. This is basically not a good idea, because when you move the position of the player directly, for the physics system behind the scene, the player moved without any time. So it's actually a very, very fast movement for the physics system. And when you have a physics box and you move the player position directly in it, you often see the box flying away. That's when you directly modify the position. And a third option would be to give the rigid body impulses instead of directly manipulating the velocity like I do. You can add a force, and I think you can even give it, and if you check the second parameter, you have the force mode. Let's give it a vector to left. And then you have the force mode where you can say force or impulse. A force is pushed over time, and impulse is a direct push for an impulse, basically, in the physics engine. The problem when working with those is they feel like, for example, like an ice world, when you walk around in an ice world, because you press right and you give the rigid body a push to the right, and it will gain speed over time. And when you start pushing to the left because you want to turn left, then it takes some time for the velocity, for the force to the left to get the velocity to the left, because it has to stop. It really feels like ice So if you want to do an ice world, then you can basically have some sliding around instead of manipulating the velocity directly. But I want a snappy feel, so I want when I press nothing, the player stands around. So I took manipulating the velocity directly. So I honor the physics system, so when we later use, maybe you could push around boxes or something. I don't know if we will able to do that, but if you are open to some physics puzzles and everything, you shouldn't trick the physics engine by manipulating the position directly. What you could do to mitigate the issue when you go to the rigid body of the player, you could set it's kinematic, and if that's kinematic, then for the physics engine it's not too heavy when walking around, and maybe we will make it kinematic anyway, so the player can't get pushed around, but we will see. Since we are here at the rigid body, I needed to add two things to my player to make him able to interact with other objects. So for example, the floor here has a box collider added. So when we check it, it has a box collider, which is basically very wide. I don't know if you see it in the video, it's a green box around it. When you press here, and then you could also move it around like that to manipulate it, or you can manipulate the values yourself. The floor has a rigid body 2D also added, which is static because the floor doesn't move around. It's easier for the physics engine if something is static. And it doesn't get pushed around, but you could make it kinematic, then it doesn't get pushed around also, but static is way easier for the physics engine because no gravity or everything is applied to it. And for this, we have dynamic. We could make it kinematic. We will see in the future. There's some playtesting to find it out. And most importantly, I freeze the rotation because I don't want, when I move the player, as you can see, his collider is a circle. And when let's play it, and I can untick it. So then you can see it. It's way easier than explaining it. What it does is basically it allows us to freeze some certain movement. So as you can see, when I walk around the player, it will turn around and everything. And when I freeze the rotation, it doesn't rotate. And I could freeze X and Y, X coordinate, and I can't move, and I could freeze Y coordinate. And in 3D space, if you have a 3D rigid body, it will work in all directions. So we want to freeze rotation because we don't want the player to rotate around, and we give everything our player controller, which we just talked, and then we manipulate the velocity to walk around. Another thing that is needed is basically the camera. And since we're using Cinemachine, it's very easy. I added 3, but the last one I'm playing around with. But most importantly, added 2 top ones. One is the brain, which is basically activating Cinemachine for this camera. And the other one is a free look camera. And what I did with the free look camera, it has 2 properties, follow and look at. And I added the player to both of these properties. And then the camera will follow and look at the player. The free look camera has a lot of features. For example, when you see when I move around, it will turn a little bit, and it will smooth and dampen the movement. And I think that's really cool. So I stayed with the free look camera. There are other cameras like a virtual camera, which is basically the simplest form, which could also follow the player. And you see a feature which we most likely won't use. It has 3 rigs. You can see the red circles. Hopefully you can see it in the video. You can see here 3 red circles. And that means normally the free look camera can move around. I have disabled that because we have a 2D game, but in a 3D game you have here mouse, I think it's mouse Y, and here it's mouse X. And I think in X the speed default is 200 or something, and let's say max speed 2. And when you do that to the camera, let's check if that actually works. No. Let's just remove it and add it again so I can show you how its default works. So when we add the player to follow and we add the player to look at, then it's very close to the player. To get it a little bit more distance, we can increase the radius, then it will move away from the player. And you can see it has 3 wicks, top, middle, bottom. And since I didn't change it now, I should be able to look around with the mouse. Or I should be able to not see anything at all. And let's say the top wick is at 10 and the bottom wick is at 10. This is basically, we are forming this doesn't look good. I don't know why this is standby, but yeah, okay. Okay, because we use the new input system, this actually doesn't work out of the box. We have to write some code, but we don't want the feature anyway, so. But I want to explain what it does. Let me just put everything back in where I had left it. This looks good. So normally you could, with those input axes, move around and turn the camera. And when the camera gets up higher, it will blend in with the top wick and the middle wick, and if it gets to the middle wick or at the very top, it will go to the wick which is closest to. And if you go lower, then it will go to the bottom wick and line between middle and bottom wick. And you can say how high those wicks are and how close they are to the player. So when you have a curve configured, for example, then it should move around to the player like that. Since I don't want to use that because we have a 2D game, I set everything to 0 and removed that. So the feature is basically disabled. And you also have a feature that when you walk around that the camera does some head bobbing and everything. I've disabled everything like that. I've set my radius to 70 because that's far away enough that it looks good in my opinion. And since I'm only using the middle wick anyway, I just configure everything pretty much the same as the middle wick. And for the middle wick, also what I have configured is a dead zone, which is a really great feature in my opinion. When you go to game window guides, then you can see the guides how the camera is working, and you have to be in a game window. And what it does is, what I did is, I set the position to 18. Normally let's configure all wicks. No, we are at the bottom wick actually, and normally it will look at the player directly, but I want to look a little bit above the player, and the yellow dot makes it visible where we are looking at. So we are at 18 units above the player. Is that too high? Maybe. Let's play test it. Yes, that's actually too high. So let's put in 15 maybe. It's live, and yeah, since we modified it in play mode, actually let me revert back to let me just load the scene again without saving. So we are back with our camera, and we were talking about the dead zones. And what I did, I added here dead zone 0.5, which is actually, in my opinion, too big. So maybe we want to 0.35, and it has a width and a height. So the black box will change. And what it actually does when we play around with the camera, let's turn it back on now. So the camera doesn't move only when we go outside the black box, then it will move the camera, which you don't see because we have no anchor point. Let me start up a second client. Yes. So we have you see the camera isn't moving, and when we leave the black box, then the camera is following. This is basically a dead zone, and this is a feature that you get out of the box, which is really great in my opinion. And yeah, that's basically how I set up movement. Disconnecting player isn't disconnecting here, but we will handle that later. So I basically just added Cinemachine Brain, Cinemachine Free Look to my main camera, configured it, very simple, added the player to follow, look at, removed everything, and added dead zone and radius to get far away from my 2D scene, and then configured the dead zone. And that's actually everything I did. There's no code, anything involved. The camera is following now with the dead zone. And for player controls, it's basically adding the new input system, and we could also test if the gamepad thing is working. But I have to stop the video and get my gamepad. I'll be right back. Yeah, I'm back. I've bought a PS5 controller. When I move the stick, it's actually working, and I didn't change anything. It's just working like we wanted to have, because we added the controller here, and so we can move around with the gamepad and the keyboard, and you actually have specific gamepads if you want to have, for example, Switch controller might want to work differently in your game than the average gamepad. You have overrides for that. So we're actually able to walk around on the map, and the next video we will talk about map partitioning and how that works, and we clean everything up, that when a player disconnects, the other players don't see him anymore and everything like that. Have a good day. Bye.